Welcome back. Here we are getting ready for the second of our introductory videos to the physics class. We've already discussed the calculator classroom policies, and we've looked at significant figures. Now, let's head on to scientific notation. Scientific notation is a convenient method for writing very large or very small numbers. It was originally devised for use with a slide rule. And believe it or not, these things really did work. In fact, I took the class in 1971, how to use a slide rule, because I was headed towards science classes. They really work. You convert numbers to scientific notation, and then you can add, subtract, multiply, and divide by simply lining up the slides. The circular one is still in use to this day in the Air Force and the Navy. Technical sergeants and master chiefs take pride in how fast they can calculate a shooting profile. So, very large, very small numbers originally devised for a slide rule. What's a very large number? Well, a very large number would be this one, 602 sextillion. What? 602 sextillion? What kind of number is that? Well, that number is also known in chemistry as Avogadro's number, 6.02 times 10 to the 23rd, the number of molecules in 1 mole of a substance. So, to write in scientific notation, you first write the first non-zero number as a decimal, and then count the number of places you have to move the decimal point. Write the number of decimal places as a power of 10. You use a positive power if you're moving to the left, a negative power if you are moving to the right. On calculators, especially the Texas Instruments family, this will appear as a double E, Casio's an EXP key. If you're looking at something on your phone, good luck, know how to run your own phone. So a very large number like Avogadro's number. How would I write this? Well, the very first non-zero number that is important is 602. Write this as a decimal. And then count the number of spaces you have to move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So write that times 10 to the 23. When you put this in your calculator, when you reach for your TI family, you will find a double E key. You would type in 6.02 double E 23. This will then usually appear on your screen as 6.02 E3, E23. So very large numbers, a positive power that gives you the number of decimal spots that you've moved the decimal point. How about a very small number? A small number like that one. Oh my goodness gracious, that's itty bitty tiny. Milli, micro, yeah, way the heck out there. What is that? Well, it's a fundamental constant in our universe. That is Planck's constant, h. It is a value found in all quantum mechanics calculations. 6.627 times 10 to the minus 34. Or 6.627 double E negative 34. Again, how do I get this? Write the first non-zero number as a decimal, 6.627, and count the decimal spots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 33, 34. And since I moved the decimal to the right for a small number, it is a negative 34, 6.627 times 10 to the minus 34. So, do I have to use scientific notation? Well, no. This isn't our first rodeo. But when we get to energy, relativity, and quantum mechanics, the numbers get big or small in a hurry. Sure, 3.0 times 10 to the 8th, the velocity of light in a vacuum. If you really want to write this value down as 300 million, well, fine by me. However, you will find that it's easier in scientific notation. Thanks. See you next week.